today we have to start new chapter, that is NoSQL databases. Okay, so this chapter is important because whole big data processing and all the activities they are carried out on this NoSQL databases. In your BTech second year or third year, you might have gone through the database management system, that was the relational database management system by SQL. Few more questions naturally one have in his mind or her mind, why this NoSQL database technology came, and what is the purpose, and how it is different from conventional relational database technology. So when we say NoSQL, SQL is a language. Okay, SQL is a language. So somebody will infer that NoSQL means SQL is not there. No, it is not like that. And what it is, we will see in the slides. So you see what is written here, motivation. Motivation means why, what is the objective of this MySQL, etc. like question. So trends today we have big data interconnection, and very high scalability. We have a lot of data, and all those data come in the category of unstructured or semi-structured. Semi-structured, unstructured data, I have already explained several times. The relational data is supposed as structured. It is well-defined row and column representation of data. And text is considered as unstructured because we do not have any well-defined structure there. And between these two extreme limits, so we have several possibilities where the partial definition of a structure is possible. So that kind of definition comes like XML database, web database, okay, and others that we will see. So all those come in the category of semi-structured. So big data, we have today a lot of semi-structured, unstructured data, and we have tag, vlog, or web pages, web links. So these kind of applications nowadays are common, and we have that kind of data. And they are available in a very huge size. Okay, that we discussed in the beginning of this database, big data analytics. So huge data, variety of data, and many applications. So how these new data should be managed? And earlier we have the established technology that was the relational database management system, and those relational database systems were used or have interface or language interface, that was the SQL. But that relational database was not so much suitable for representing all these semi-structured data or new applications of data. And if we try to represent forcefully, then a lot of other complexities arises. So technology needs some convenient mode of representation and easy mode of implementation and later easy mode of using. Only then the technology is supposed to be successful. Okay, so other issues were like database administrator. In relational database management system, not very common user was able to design schema, able to implement. Okay, so database administrator was one person who used to take care to manage the system itself. database management system. And one extra person to train in that area was requirement. So need for a skilled DBA and well-defined schema, SQL and complex tuning, that is different thing, and hard to make updates scalable, parallel relational database management system, and shared disk online transaction processing, and distributed databases. All these were the requirement of the current area. Okay, so this database technology was, if we try to apply even in for distributed database, then we have some problems that we will see here. So we have several such issues that motivated, or they are the answer for this new development. And one new theorem came. I told in previous class there is a theorem. So that theorem is CAP, C-A-P, consistency, availability, and partition. So earlier it was expected that the database management system should have all these three properties. Later on, it came to know that if we try to relax out of these three one condition, one property, then we have so many kind of easy solutions for the database management. So we will see, and by relaxing one condition out of these three, two properties, we have developed so many this NoSQL databases. So following terms are used in practice for NoSQL database. We have NoSQL database, we have non-SQL database, we have not only SQL database, we have non-relational database. All these refer to the same thing. And here we basically want to refer that a database that we will use here, they are not relational database. And people were also not happy because the cost of relational database management system was very high, and in market only few limited number of companies were dominating, and their solutions like Oracle or other Sybase, SQL server. Okay, so to take load of huge database, they used to charge a lot of money. So that is also one problem. Second, new applications that were not able to be easily solved using relational database technology. Okay. So people started to search solution that is not using SQL. So somebody started, it is NoSQL database. Okay. Somebody told it is non-SQL database. However, here SQL has no relationship because SQL is a name of the language that is used with relational database. Okay. Then somebody said that not only SQL, we have other kind of solution. But if you see non-relational database, this is appropriate term. Non-relational is more appropriate compared to other NoSQL, non-SQL, but all refer the same meaning, that we are talking about non-relational databases. So people want to say NoSQL databases are databases that store data in a format other than relational table. In relational schema, what we have, first of all, we have to define the schema, we have to define the structure of table. Only then we are able to insert the tuple. And we have to insert tuple only according to the definition of table. So it has somewhat fixed schema. And we want that our data, that was the web data or vlog data, so many kind of e-commerce applications generate data. So that could be fit. So we have to fit only that tabular definition. Okay. So non-SQL databases are databases that store data in a format other than relational tables. NoSQL is an umbrella term. Umbrella term means in English language, if we want to define several things by a single term, we used to say it is umbrella term. So NoSQL is an umbrella term and it describes several categories of databases. Several categories of databases, basically, when we say NoSQL database, that means it is not referring to one kind of database. It is referring to several kind of database. Okay. So you will see here column-based database, columnar database, value and key and value database, like that. So we will see that category here. So these databases use data structure that are different from the traditional row and column table model used in relational database management system. NoSQL databases are all quite different from SQL databases. All NoSQL databases are all quite different from each other. Now you will see when I say that it is one SQL database, it is another SQL database. That means both can be of different types. Okay. So it is not sufficient to say it is a NoSQL database. Somebody have to answer what kind of NoSQL. Key value, columnar, graph, like that. So NoSQL database features, each NoSQL database has its own unique features. At a high level, many SQL databases have the following features. If we talk about one specific NoSQL database, then its features will be explained separately. But if we try to grasp common features among all the categories, then you will find flexible schema, horizontal scaling, fast queries due to the data model, and ease of use for developer. When we say flexible schema, that means records have multiple schema. In relational database, one record has the definition according to the table defined in a schema, but here it is not the case. Record can have different structure, multiple schema. Horizontal scaling, I will explain that how this horizontal scaling is useful here. Fast queries due to the data model. In relational database, we have to retrieve data, so we use to join two or more tables. Okay, so join operation is a very costly operation. It requires a lot of processing. So here we do not have any such kind of join operation. So the query is processed in less time. So it is faster. Okay. So fast queries due to the data model, no join operation required here. Ease of use for developer. Developer can understand and use it easily compared to the relational. Whereas in relational database, special training is required for database administrator. And many students might have experience in their internship training of Mongodb, Cassandra. They are very popular database, popular NoSQL databases. Okay, that will also we will discuss. Something is written here, I read it. NoSQL is a class of non-relational data storage system with flexible data model. Examples of NoSQL data architecture patterns of data sets are key value pair, name value pairs, column family, big data store, tabular data store, Cassandra used in Facebook, Apache, HBase, hash table, dynamic Amazon S3, unordered key using JSON, HDB, JSON Peanut, JSON Mongodb, graph store, object store, ordered key and semi-structured data storage system. When we say NoSQL data storage, that means storage system, here NoSQL data can be. Okay. NoSQL not necessarily has fixed schema. You think somewhere we have the definition, some kind of fixed schema can be, but in most of the cases you will find flexible. NoSQL not necessarily have a fixed schema, such as do not use the concept of joins in distributed data storage system. Data written at one node can be replicated to multiple nodes. Data stored in thus fault tolerant. The store can be partitioned into unshared shards. Scaling means we have generally two terms very popular. At several places we have, even for this institute, somebody say this institute have need to develop vertically, and somebody said this institute have to develop horizontally. Okay, so you can also able to understand if you have this meaning of vertical and horizontal scaling. When we say vertical scaling, that means I have one computer, one machine I have, and I am using here a database system. Okay. Storing and retrieving data using my software program to be done here. Now I have larger database. Okay, so what I shall have, somebody will suggest you increase the RAM. Then I will even experiencing that system is slow and it is taking more time. Somebody will suggest have new processor instead of this current processor, and new processor should be able to deal larger CPU word size and compute faster. But in all these cases, there is some limit. Okay. At the same time, the work of developing new processor is very costly work. Okay. So, but if I want to add more and more power on the same machine, then I say this kind of expansion as vertical expansion or vertical scaling. Second solution, instead of enhancing the power of the same machine, if I take other smaller machines that have same kind of power that we have very well popularly nodes, and I make a network of machines. Okay. And because same CPU I am using, so cost of new machine with the same CPU will not be much. Okay, so such a smaller machine will be cheaper compared to developing new powerful CPU machine. So what will happen here? Instead of using one machine, I have several machines and I connect them, and I am able to get the similar power as I was doing for this vertical expansion or vertical scaling. Okay, so this is called horizontal scaling, using the similar machine more and more in number to get the same high computation. So here it is written, I read it. Vertical scaling refers to increasing the processing power of a single server or cluster. Both relational and non-relational databases can be scaled up, but eventually there will be a limit in terms of maximum processing power and throughput. In horizontal scaling, also known as scale out, refers to bringing on additional nodes to share the load. This is difficult with relational database. due to the difficulty of spreading out related data across the node. So if we try to apply this horizontal scaling for relational database, then we have difficulty. Okay. Difficulty can be like that there is a very big table, and this table, one part of table is on one machine, second part is on another machine. Okay. So if any query I want to execute, so the query first have to consult on which machine this data is present. Okay. Second, I shall have to bring from one node to another node. Only then I can do some kind of join and other operation with the other table data. So it is somewhat costly and difficult process. And this has to be done because whole database is related. Relational database, one table is related to other table like that. So that's because of that relationship. Every time I have to consult whether this table is data is present here or there. So for relational, this horizontal scaling is difficult or it has complexity. But in case of this big data, that kind of relationship we are not using. Then it becomes easy. So what happens here? This is difficult for relational databases due to difficulty in spreading out related data across nodes. With non-relational databases, this is made simpler since collection of self-contained and not coupled relationally. Okay, so each data store has data such that it is not so related as it was related in relational database. So this allows them to be distributed across node more simply, as queries do not have to join them together across the nodes. So this is the advantage, and that's why all the horizontal scaling can be used. So today we have cluster on we have this cluster computing service. Feature of NoSQL transaction. Transaction, you are aware in relational database, asset property should be satisfied. But here, NoSQL transactions have the following feature. That asset properties that we were supposed to satisfy in the relational database, here we shall have to relax them. We cannot use such kind of asset properties here. And those applications where asset property becomes is only the important issue, we cannot use this big data technology. There still relational data technology is useful. So relax one or more asset property. Out of these 4 property, 1 or 2 property have to relax. Characterized by 2 or 3 properties: consistency, availability, and partitions of cap. So 2 are at least present in the application service or process. You will learn cap theorem, and it suggests that out of these 3 property, 2 property can be ensured and 3rd property can be relaxed. Okay, relax means it is not being satisfied as it is. Okay. So you will see an example also. Can be characterized by base property. We will see in next slide. So big data, NoSQL solutions use standalone server, master, slave, and peer-to-peer distribution model. So in any form, we can use big data NoSQL solutions. So in next slide, I will show you. There are different solutions of this NoSQL big data. So I shall have to read this slide, and it has a lot of information. So we have to stay here, and we have to discuss somewhat in more detail. So here it is written NoSQL data store, and here description. The names you might be already have Listen, Apache Sbase, Apache MongoDB, Apache Cassandra, Apache CutsDB, and Oracle NoSQL and RAC. So they are the names of the NoSQL databases, and who has developed and what purpose. So those things are written in description. So I read it: Apache HBase, HDFS compatible. This is HDFS compatible, open source and non-relational data store written in Java. A column family based NoSQL data store providing big table like capability. Okay. Scalability, strong consistency, versioning, configuring and maintaining data store characteristics. Second is Apache MongoDB. This MongoDB is very popular, and nowadays MongoDB expertise or people have training in this MongoDB. There is a demand in market, and you will find also online there are several MongoDB courses they run. It is IDFS compatible. IDFS we have discussed, distributed Hadoop distributed file system. So IDFS compatible master slave distribution model, document oriented data store with JSON like document and dynamic schema. Open source, NoSQL, scalable, and non-relational database. Okay, it is open source, NoSQL, scalable. Okay. Used by websites, Craigslist, eBay, Foursquare, and Backend. They are the name of the website that use this MongoDB. There are many other websites also. Here they are not, but when we have discussion on MongoDB. So next is Apache Cassandra, LDFS compatible databases, decentralized distribution, peer-to-peer model, open source, NoSQL, scalable, non-relational, column family based, fault tolerant, and tunable consistency, used by Facebook and Instagram. They are the social sites, social networking sites. Apache CutsDB, a project of Apache, which is also widely used database for the web. Okay. CutsDB consists of document store. It uses JSON data exchange format to store its document. JavaScript for indexing, combining and transforming document, and HTTP API. Oracle NoSQL, step towards NoSQL data store. Distributed key value data store provide transactional semantics for data manipulation, horizontal scaling, horizontal scalability, simple administration, and monitoring. RAC, it is an open source key value store, high availability using the application concept, fault tolerance, operational simplicity, scalability, and written in Erlang. It may be some name of lang. Okay. So they are somewhat more popular databases, but if you go on net and if you try to find very large number of NoSQL databases, actually what happened here when this relational database technology was dominating the market, and these new e-commerce based or web based applications, they require to manage their huge data. So keeping in view the unnecessary monetary demand of these dominating relational database company, some companies started to develop their own solution. And what happened here, many such NoSQL databases came into existence. Okay, then second, the open source technology also was dominating in this area. So today we have many NoSQL databases, and we can choose depending on our own requirement. This is CAP theorem. This theorem has some dispute or controversy. Few people are agree, few people are not agree like that. Okay, but you do not worry about this kind of argument. You have to simply understand what is CAP theorem and how or where we do use in this NoSQL. So polemical involving dispute or controversy topic है ये थोड़ा. A database cannot provide consistency and availability during a network partition. It is simply saying that suppose we have a network and suppose we divide it. And or we can say there is a failure of network. And still we want to ensure the consistency of data. So it is saying that it is not possible. Consistency, even then the partition has been done or some failure has taken place. Second, availability. The data should be available on the whole network, even then the failure has been taken place. So it is saying a database cannot provide consistency and availability during a network partition. ठीक है? Argument used by NoSQL to justify their lack of asset properties. So you will see here in very social network website. Suppose we have data of social network. So social network website, the data is not like that is to be used by satisfied by this asset property. It is not so important. Suppose my address is changed today, okay, and if you see on website somewhere there may be some outdated address, okay, but it is not so much serious case. If there is a transaction, monetary transaction, suppose some money is transferred or deducted from my account and it is not being visible to me, so it is somewhat serious compared to my address is changed and some other person want to use it. So what happened here, I make a system such that my address is changed, but new address that will appear after a gap of time. Data is not consistent, but later on, eventually it will be consistent. Okay, so okay, no problem. After a few hours, you will get my current address like that. So several such applications where this kind of seriousness is not there, we can relax that condition. So here, NoSQL data store, they have this kind of argument, but has nothing to do with scalability. Scalability is different thing. And today, the hardware cost is less, so we have cheaper nodes available. So one will always be argue in support for cheaper or less cost product. So we can use that. So these kind of things are there. Two different points of view: the relational database and distributed database. So this is consistency essential for the relational database, and this distributed database service availability essential. So here for three terms we will discuss CAP, and then we will see that only if we consider two out of these three property and if we select the third one. So depending on which property has been selected by the database system, several solutions of NoSQL we have. So what is CAP theorem? The desirable property of a distributed system is consistency, availability, and partition. They should be present. Okay. So consistency says all nodes see the same data values at the same time. It says if I change my address here, then it should be reflected on some other node also. Availability, all requests get the answer. Suppose I put my query here and data is not present, but it is present somewhere else. Even then, I should get my answer all the time. So partitioning tolerance, the system keeps functioning in case of network failure. If so, all these three should be satisfied. They are the desirable property. This is some historical paper and argument, so we are leaving these two. Then strong consistency concept parties and strong versus eventual. Strong consistency say all nodes see the same data values at the same time. This is called strong consistency. One more new term while suppose that is called eventual consistency. Some nodes may see different data values at the same time, but if we stop injecting or update data, the system reaches strong consistency. Okay. So it is simply saying that suppose I have changed my address and I am not going to update it. Then after a few time, my old address will be updated and people will get the current address. So this kind of situation. Illustration will with symmetric, asymmetric replication in databases. This is simply a diagram. It is showing you eventual consistency. So database failure. After reconnection, the resolution of update conflicts and resolution update conflict consistency will be obtained. Something is written about cap theorem here, so I read it so that you have better understanding. Among CAP, C consistency, availability, and P partitioning, two are at least present in the application service process. Consistency means all copies have the same value like in traditional databases. Availability means at least one copy is available in case a partition becomes inactive or fails. So at least one copy. For example, in web applications, the other copy in the other partition is available. Okay. Partition means parts which are active but may not cooperate or share in distributed databases. Consistency in distributed databases, availability, and partition. So consistency in distributed databases means that all nodes observe the same data at the same time. Therefore, the operation in one partition of the database should reflect in other related partitions in case of distributed database. Operations which change the sales data from a specific showroom in a table should also reflect in changes in related table which are using in that sales data. So this is the consistency in distributed. Availability means that during the transactions, the field values must be available in all partitions of the database so that each request receives a response on success as well as failure. Failure cases, the response to request from the replicate of data. Distributed database require transparency between one another. Network failure may lead to data unavailability in a certain partition in case of no replication. Replication ensures the availability. So we have to replicate. You see here we ensure this feature by 3 times, minimum 3 times application of the data in Hadoop. 3 or more. Partition means division of a large database into different databases without affecting the operations of them by adopting specified procedure. This is one more property, partition tolerance. How do we define? It refers to continuation of operations as a whole, even in case of message loss, node failure, or node not reachable. Reverse cap, it is consistency, availability, and failure tolerance. Availability and partition tolerance theorem demonstrates that any distributed system cannot guarantee CA. This is the theorem. Any distributed system cannot guarantee all these three. Consistency, all nodes observe the same data at the same time. Availability, each request receives a response on success failure. Partition tolerance, the system continues to operate as a whole even in case of message loss, node failure, or node not reachable. Partition tolerance cannot be overlooked for achieving reliability in distributed database systems. Thus, in case of any network failure, a choice can be database must answer, and the answer would be old or wrong. Okay. Database should not answer unless it receives the latest copy of the database. So this is called consistency and partition. This is called availability and partition. So these two, if we take, then we can go ahead. The cap theorem implies that for a network partition system, the choice of consistency and availability are mutually exclusive. Consistency and availability, CA means the consistency and availability, AP means the availability and partition tolerance, and CP means consistency and partition tolerance. Okay, for the one. So one diagram is cap theorem in big data solution. Consistency, availability, partition tolerance. So if we take consistency and availability, these two, CA, then they are the solution. Then this availability and partitioning. This is consistency and CP. RDBMS, MySQL, PostgreSQL, CushDB, Cassandra, DynamicDB, HBase, MongoDB, Redis. Cannot be SQL. A specific database management system for web databases, specialized data model, key value, table, document, and graph, trade relational database, full SQL, ACID, transaction, simplicity. This we have covered. Now, what are the approaches, or what are the categories? Okay. So characterized by the data model in increasing order of the complexity. Key value, tabular, document, graph, and multimodal. Okay, so they are different categories, and in each category one name is also shown here. What are object database management system, XML database management system? Was there much before NoSQL, sometimes presented as NoSQL, but not really scaled. There are few names of the database management systems, NoSQL databases. They are the name of company, vendor. They are the product name, category, which two properties are out of this cap theorem. And which category, what property, sorry. This is vendor, this is from which company, this is the name of the product, NoSQL database. This, so Amazon DynamoDB key value. It is a property. That means it is not open source. Apache Cassandra, Akamlo, a key value and tabular. It is open source and organization is open source. Facebook and this is named company Forage. This is open source and asset they are using. Couchbase name of vendor. It is product name, key value and document oriented. Origin name. Google Bigtable, tabular and property patent. Facebook DogTV, KB key value open source. Hadoop HBase tabular open source. LinkedIn Vodomort Espresso key value document open source asset transaction. 10GN, 10 generation MongoDB. This company 10GN, 10Gen document open source. Oracle NoSQL name of the product NoSQL. But NoSQL is a general term. Key value based on the Berkeley DB. OrientDB, okay. Graph KB, open source. Neo4j Graph, open source. Ubuntu company, CouchDB, document open source. Out of these databases, this is Neo4j. It is popular for graph. Okay. Second, MongoDB, also very popular. And third, Cassandra. Okay. Now, key value store simply it is a simple key value data model. So it unique key and value can be a text, a binary data, a structured data, anything can be. So key value pair. So simple query, we store data as key value pair, key value, and key and value can be any one of these things. Not like in database, relational database, value is like student table key and they are the attributes. It is not like that. Whole text can be one attribute, one value, one binary data can be structured data. And query will be put key value, insert. Will to get value, key is there, then value you will get. Key pair, then you get key value range result. So it is a set of values, key and value, key and value. Amazon DynamoDB, major service of AWS for data store. For example, product list, shopping cart, use preferences, data model, key structured value, data model, partitioning on key and secondary indices on attributes, simple queries on key, flexible, no schema to be defined, but automatically inferred. Consistency, eventual consistent reads, default, strong consistency read, atomic updates with atomic counters, high availability and fault tolerance. Synchronous application, Instagram with other AWS service, Amazon Web Service, identity control and access MapReduce. So for different purpose, this is DynamoDB. We are DynamoDB data model table. Table item key attribute, two types, primary unique key, hash, one attribute, hash, range, two attribute. Attribute of the form, Java API with methods, add, update, delete, get, item, primary key, return the item. So batch get item, scan, query, range on hash, range key access. So just for brief understanding, this is structure, this kind of data. Consistent hashing advantage, data replicated on next. The interval of hash values is treated as ring. Okay. Node B is responsible for hash value interval AB. Thus, item CV is assigned to node B. Next category is document store. So, in our application document system, content management system, catalog, personalization, analysis of message, tweet, okay, in real time. So for this kind of application, this document-based NoSQL database. So data model for document hierarchical structure with nesting of elements, weak structuring with similar element, base types, text, but also integer real date, two main data models, XML and JSON. XML extensible markup language, W3C standard 98 for engaging data on web, complex and heavy. Data on Java, data JavaScript, simple and light. Okay, it has come 2005. Earlier we have, well, in 1998. Okay. MongoDB is one example of this one. Objective, performance, and scalability. A document is collection of key type value with a unique key generalized by MongoDB. Data model and query language based on JSON, binary JSON, BJSON, most compact. No schema, no join, no complex transaction, shared access and integration with MapReduce and Spark. MongoDB collection host. MongoDB query language, expression of a form. This is the way, this is database name, this is function, database post, insert, author. Okay. Select example in MongoDB architecture. Main NoSQL JSON database, vendor Apache, product language, open source, Apache CutsDB, NoSQL JSON database, open source, Couchbase, and NoSQL, open source, DJ JSON, EJDB org company name, EJDB, MongoDB, like open source, linked in Mark Logic, JSON language, MongoDB, MongoDB, JSON, Jobra. So JSON database management system. Tabular store, other category of data, NoSQL database. Database storage system for shared nothing cluster uses GFS to store structured data with fault tolerance and availability. Used by popular Google application, Google Earth, Google Analysis, Google Plus. The basis for popular open source implementation, Hadoop, HBase on top of HDFS, Apache, and Yahoo. A specific data model that combines aspects of row store and column store DBMS. Rows with multi-valued time-stamped attribute, dynamic partitioning of table for scalability. A big table row. Name, email, web page. Column family, a kind of multi-valued attribute. Unit of access control and compression. Big table API, no such thing as SQL. Basic API for defining and manipulating tables within a programming language such as C++. No impedance mismatch, various operators to write and update values and to iterate over subset of data produced by scan operator. Various ways to reference column and timestamps produced by scan as in relational select, but no complex operator such as join or union. Transactional atomicity for single row updates only. Dynamic partitioning, dynamic ring partitioning. This is graph database, DBMS graph, very big. Most of the social networking problem, they are modeled by graph. So very big billions of nodes and links, many millions of graph. Main application social network, recommendations, sharing, sentiment analysis, master data management, reference business object, data governance, fraud detection in real time, e-commerce, insurance, enterprise network, impact analysis, quality of service, identity management, provenance, graph partitioning. Okay. Objective get balance partitions, NP-hard problem, tunnel algorithm. Solution approximate heuristic based on graph topology. Neo4j, direct support for graph. Data model API, query language, implemented by linked list on disk. Implemented by linked list on disk, optimized for graph processing transactions, implemented on SN cluster, asymmetric application, but no graph partitioning. Planned for future version. node links between properties on nodes and link in your transaction. Okay. Language Java API, Cipher query language, queries and updates with graph traversal support is for RDF. Neo4j architecture, write transaction, read queries, synchronous application. Multi-model store, Orient DB, integration of key value, document, and graph. More than one category of type have been incorporated. Extension of an object model with direct connections between object nodes, SQL extended with graph traversal. Distributed architecture, graph partitioning in cluster, symmetrical application between data centers, asset transactions, web technology. So this was about a brief discussion on this NoSQL database. Okay, thank you.